All right, let me start here. Welcome to this training. I will give a call routing introduction for all the TelcoBridges products, including TMG devices and ProSBC devices. So in this presentation, I will talk about the basic call routing and all the call routing functions, including priority, regular expressions, route retry, call limiting. I give you tips on troubleshooting, just a glance on advanced call routing functions that are available, and I will give you a small demonstration on these call routing features. So if I start with the basic call routing for ProSBC, since ProSBC supports SIP calls, you can get SIP calls from service providers. Any service provider connecting to the ProSBC can send a call. And when the call is received in the device here, there's a call routing function here that is used to decide where to route these calls. And then according to what is decided in the call routing, it will be sent to the different service providers here. We can do the same thing with our media gateway devices, the TMG devices. However, there's more protocols involved when we're using a media gateway. It can be all kinds of TDM protocols like ISDN, SS7, CAS, GR303 coming into the TMG device here. The same thing happens. You have call routing, and these calls can be sent either on the SIP side or back out to the TDM side here. Here I show we also support SIP-I. This is true for SBC and also media gateways. So routing can be done in any fashion on all these networks. The functions that are available for routing, like let's say the basic functions that are available, you have the call number, the calling number, the network access point. So that means where the call is coming from. Could be SIP, SS7, or other protocols there. We have priority routing, load sharing for calls, regular expressions. We can remap numbers and networks. And also we have a route retry function. So we're going to go through each one of them here. When you connect to our web portal, you will have at one step here, routes, where you will see a table that will pop up. Initially, it will be empty, and then you need to fill that up with information. The information is divided in different segments. You have here incoming attributes. So this is information that is coming from the network where it's called. Then you have outgoing attributes, is our information that are going out to the outgoing network. And then you have additional route settings that can be done here for different functionalities. Right? So the incoming and outgoing network access points are here. These can be, of course, SIP networks or other TDM protocols here. And the outgoing NAP, same thing, can be SIP or other networks here. The default custom attributes that are always included is priority and wait, which are used for load sharing and priority routing. If I start with the function of priority routing, so what you will have here is you need to set up the priority settings for each of the routes here. When you set that information, it will be the lowest value that will be selected first. So for the same incoming attributes, the priority will be identified for each of the routes, and the lowest value will be chosen first. So in this example, the main route is chosen first because it has the lowest value here. So the call coming in from this network access point will go to this VMA1, which is another endpoint on the system. If this one is not available or is refused, it will go to the next one here, which is called NAP3CX. So that's a PBX we have here in our lab. It will go there. If that one fails, it's going to go to the third one. When you set up load sharing, what you have in this case is a wait setting. So for priority that are equal, for example, 10, 10, 10 here, if it's the same priority, the system will use the weight attribute to distribute the calls amongst different endpoints. So for example, here, these are calls coming from this network, and they could go to 3 different endpoints here, and it will be distributed among according to these values here. So for example, in this case, load share 3, since the value is much higher, it will have 2 times as many calls as load share 2, and load share 2 will have 2 times as many calls as load share 1 here. And as an example, if you put 350 calls in the system, you will get approximately 50 calls for load share 1, 100 calls for load share 2, and 200 calls for load share 3. So you can add more load share routes with different weight, and it will distribute amongst all the possible routes in the system. You can have a regular expression. So I here in the previous examples, I showed just NAP routing. So we only look at the incoming network. But of course, you can also filter according to the incoming number, either the call lead number or the calling number. Okay? So you can have different values here, and you can set straight up numbers, or you can set regular expressions, which is usually what we do. When you set up a route like this, you could use an app which is any, meaning I don't care where the call is coming from. I just want to route this number. So you can put any, but you could also have regular expression specifically for a network as well. So this example of a regular expression, okay, accepts only numbers starting with 450. This can be set for call lead number or calling numbers. So this is the example I just showed here, 450. Okay. So so the number needs to start with 450. So the information you have here in the regular expression is the initial bars here are the delimiters. So it just shows that the regular expression is in between those two bars. You have the caret here, which says start at the beginning of the number. So here it's 450. So that means the number needs to start with 450. Okay, so the first number needs to be 4, 5, and 0. Here, the square bracket, 0-9 square bracket, means 1 digit from 0 to 9. Okay, so if you put only 0 to 9 with square brackets like this, it says only 1 digit. However, if you put a value like this at the end, so curly brackets here, 7 curly brackets, this means 7 digits of 0 to 9. So you can have 7 digits here. You could put 10, you could put less than 10. And the $sign at the end just means that this is the number needs to end at the last number. Okay, so you cannot have a portion of the number. It needs to be the full number when you put the caret and the $sign at the beginning and at the end. All right, so this is an example. But there's other tricks that I just want to mention. Instead of specifying curly brackets of 7, you can say star. That means any number of digits. If you have an optional, for example, if your number could start with 1, then you could have a question mark like this. So you put 1 question mark, so that means the 1 is optional. And then there's some characters which are reserved, and mostly we use only the plus when we work with the SIP network. So when you use a plus, you just need to make sure you escape it with a backslash. So backslash plus means this is a plus. Okay? So just small tricks here for a regular expression. With what I just showed you, you can probably do 95% of all the cases of regular expressions on a system like this. You can also do regular expressions for remapping. Okay? So you want not only to filter specific calls coming in, but you also want to replace those values with something else. Okay? So these are examples for call lead number, and these are examples for calling number. For example, this one here replaces 450 which is here, with 514, which is here. Okay. So for example, the incoming number could be something like this, and the outgoing number will just replace the prefix like this. And you can do the same for called and calling number. So in this example I just showed you, these are the same values, right? The slash here, and slash here means delimiters. 450 is what you need to have here. 7 digits is what you need to have here. And the parenthesis, which we added in this regular expression, is to show that this is a group of numbers that we will use for replacement. Okay? So the first set of parentheses means group 1. Second set of parentheses will mean group 2. Right? So this is to capture the data here. Then this is the part which is the replacement. So the replacement here, it says 514. So if you put a number there without any other information, it means a direct replacement of the numbers. And then you have \1 here, which means replace with first group in parentheses. So the number will be, the resulting number will be 514, and the 7 digits which were captured here on the incoming number. For specific cases, you can also use single numbers or complete numbers in the attribute. So for example, you choose a number like 1111 like this. Only this number will be accepted to choose this route. So let's say I call it route specific 1. It will get only this call number. This is usually when we want to do some test calls in the system. So we can add specific routes like that. And if it's this number or this calling number, let's say you want to call from your cell phone in the system, then you can put your own calling number and it's going to absolutely choose this route if the priority is higher than any other route using that same information. Here in this case, we also remapped the call number. So if the call number was 1111, here we replace it with this number. The route retry function, so the system will make a call to the first route that was selected. If it fails or for any kind of reason, it may try the other routes. Okay? So by default, most of the time, it will try the next route. In this case, there's 3 routes possible, main, secondary, and third. So it will go through the priority settings. It will try this one first, then this one, then this one. There are configurations that we can do for the route retries. These are available in the gateway section, advanced parameters here. So by default, if the call is alerted, right? So alerted is receiving a 180 or 183. If the call is alerted, then it will wait. It will stop the timer. Okay, so if until the call is alerted, it will wait only 10 seconds. As soon as the call is alerted, it will wait until the next step is accepted. Okay, so when the call is accepted, then it will stop the timer and everything will continue. If the call is not alerted, okay, for 10 seconds, and that's the default case here. If the call is not alerted for 10 seconds, it's going to start right away on the next route. Okay. So these values, of course, as you can see, can be changed here, change the timer, or you can change when the information is received. Okay, so it could be, instead of call accepted, it could be call alerted. Okay, so actually, yes, call alerted is 180, 183, but you could just say call accepted, which in this case would be 100 trying on SIP or other information on TDM networks. In addition to this, we also have configuration profiles for adjusting when you want to try the next routes. Okay? So there are default configurations in the system already. So if you go to those profiles, you will see what has been decided in the system. For example, If we get a 603 decline from the remote side, we will continue call or continue to the next route. If we get the 604, we will stop routing to the next route. Okay, so the call would be terminated right away. So there's all these settings that are done, and we can change them. So you can just click on these elements, change this from continue call to stop call. And when you see here reset to default, it means something has been changed in this specific route. These are SIP error codes. If you are using the TDM side, these will be the TDM error codes. For example, 17 is user busy. And then you have the other codes here, like unallocated number and these things. All right, so you can adjust all of that for each of the networks. The last function I wanted to show you for the call routing is the call limiting function. So you can limit incoming or outgoing call rate. You can limit incoming or outgoing number of calls. And this is all configured per network. And we can configure this in the profiles. Okay. So maximum calls per second, that will be total over that network. Maximum incoming calls per second for that specific network. So let's say you don't want someone to send you more than 25 calls per second. You can force here 25. And if there's more calls than that, the other calls will be refused. You can also limit the number of outgoing calls going to a specific network. These are calls per second, so a call rate. You also have here number of calls. So here you can say, I don't want to send more than 500 calls to this particular network at a single moment. Okay? So you can put here 500 calls, and this will limit the number of outgoing, incoming, or total calls on that network. Right? So troubleshooting tools for call routing, I think the call trace is probably the best tool, and I will show you that in a minute how to use this. If you can't get enough information in a call trace, you may want to do a signaling trace. So TB6 trace is the application we use for that. And if you can't figure out what's the problem, maybe we need to do a TB report and get the help from our support team. In that case, most likely we will ask to have a gateway application at trace level 2. So we get a bit more information on what is the call routing, why was it not accepted or not routed to the correct destination. So I will go through these tools in my demonstration. Just a note on advanced call routing. So now I showed you all the basic call routing functions, but when you get to more complex network, we can have advanced call routing. We can enable scripts in the system to adjust all kinds of things we do with the calls that came in and how we send the calls out. We can add information, remove information, create algorithms for different scenarios. And this can all be done with the advanced call routing system. Additionally to that, we can access external systems, for example, HTTP servers with REST APIs, SIP redirect server, and Radius AAA servers to allow us to do even more advanced call routing functions. Right? So I will show this in other trainings we'll do later this year. Documentation we have, call routing, configuration for call routes, troubleshooting, T-Media and SBC, support T-Media and SBC. I'll show you those links in a minute, but you have them here. The lab setup I want to use for demonstration, I have a 1+1 ProSBC system here, which I enabled some call routes on the system. You have another ProSBC here, which I will generate SIP calls to the system here. And then we will have calls going out. I have 3 different networks here to demonstrate the priority and the load sharing. Calls here on VMA1 are not allowed. This one is completely down. So I have a network that is not accessible. And this one will answer all calls that is being sent to them. So I'll show you the test call function uh, for this. So let me move on to the demonstration. So this is my VM82 system. It's a 1+1 system. Maybe I can show it here. Hosts. Yeah, so you see you have two servers here handling the system, and you have all the information on the status of the system. In here, I have my route. So if I go down here, I click on routes. Oops, right here. So I click on routes. So I have my list of routes. These are the routes I will be testing with you here in the system. And what we have also is the call trace, which is here. So I click down here on call trace, and I will have a list of calls that came in to the system. These calls can be, if I click on one of them, I can export, oops, sorry, here, I can export these in XML format, and it will have the same display as here. You will see what has been received, sent. You see some of the SDP information if it's a SIP call. You see also all kinds of things here like MOS score, network ports used for RTP. Right, so you see all this information. The test calls will be done from my system here. So so this is VMA1. So I don't see it here, but this is VMA1, and I generate outgoing calls to VMA2, which is my test system. And then I can change the called and calling number here for various tests. Yeah, there's one more thing I wanted to show you here. If I go, I want to show you the profiles. If I go here, modify reason cause, and I go down to edit reason cause mapping. Here you have all the route retry action. You see, oops, some of them will be stop, some of them will be continue. But if you want to continue on an unallocated number, you can just change this to continue call. Process call routing is for a different, it's a 302, so different configuration of the system. Guys, you can change this per network uh, here because it's a profile. It's a profile, and the profile are attached to the network access points. So for example, NAPSIP VM82 has a specific profile. Whoops, it's here. So you can change the profile here for a new reason cause modification. Okay. Yes, the other thing I wanted to show you was the call rate limiting. So you have to go here actually in advanced parameters, click on call rate limiting, and here is where you can put values on limiting limits, call rates or number of calls. Again, this can be adjusted per network because it's configured per network. Okay, so let me start the demonstration here. The first call I will do will be a priority. So priority, I will be using call lead number 555 here. So I can place a call with 555. And I have three possible routes here. The first route is 10, 20, 20, 30. So that means it's going to try this one first, then the second one, then the third one here. So if I go here to my list of call trace, so this is the call I made just now. If I click on main route here, well, let me just go back first. If I have main route here, I can see that this is my incoming call. Okay, so it came, whoops, sorry. It came from NAPSIP VMA1. Okay, incoming. So that's a call that came into the system. It had it tried three different routes. The main route here, which is VMA1 here, outgoing, and I received a 503. So this means go to the next route. Here, secondary route UAC, we know that it's not active. So 480, we receive a 480. So we tried the third route, and now the third route is the call is ongoing. This is going to my SIP server. So the call has been answered. If I stop the call on my test system, I will see now that the call has terminated 68 seconds later. I have data on the network quality. So if I click any one of those, I will have the same information because all of them are one single call with multiple routes. So you see this is the incoming network here, and you see the three possible routes that were sent. And if you look down here, you'll get more details. So the call came in from this network to this IP here. It had this calling number, call in number. Here it says it found three matching routes: main, secondary, and third route. Um, and then it sent the invite to the first one. No answer, so there's a cancel. Send invite to the second route. We receive a 180 ringing, 200 okay, but then and wait a second. This is the third route. So this okay. So the first route is here. Sorry, the first route is here. It was never tried because it's not available at all. So it didn't even spend time to send a call there. It knows that it's not available. The second one, it did send a call and then it didn't answer for 10 seconds, I guess. Yeah, 10 seconds. Then it was canceled. The third one we did get an answer, and then the call went on for uh, 68 seconds or a bit less here. Okay. And this can be exported, as I mentioned. All right, so this is the first test. Second test is the load sharing. So now I'm gonna use 444 here as a call number. So it chooses these routes here, and I can place my call. Then we can go here into uh, the results. Okay, so the call is currently ongoing because it reached the UAS and now it's working. So I can stop the call here to end it. So now I know that it has been, well, actually 12 seconds. Here, what you see is we received the A1 guess, and then it used the route called LS load share 2 first. Okay, LS load share 2 first. This is the one here. Okay, so at this moment, it chose 2 first, then it chose 3, and then it chose 1. Okay, so it went this one first, this one second, this one third. If we do the call again, it chose 3 and 1 and was answered, so it didn't even choose 2. But if we do it again, it could be something else. Right? So in this case, it went to 1 first. Oops. Let me just check here. It went to, it did try this one first. And since it was not available, then it went to the second one right away. Okay, so it's gonna modify because it's load sharing. It could be 1, 2, 3 that is chosen first. Over time, since my load share 3 has a bigger value, it should be more load share 3 that is being used in those routes. Okay. Let me stop this call. The third is a regex. So I want to use a call number like this one. So, oops, well, let me go here first. The regex is, well, the number that I dialed is 450 1, 2, 3, 4, 5, 6, 7. So I see that it chose regex route 1. So I can go here, regex route 1. So you see here the call lead number is 450 and 7 digits. So if I send a call with 450 and 7 digits, it's going to use this route for this call. Calling number. So it's the same here, except that it's the calling number that I'm using. So this, I'm gonna refresh this one. So now you see here, it shows regex route 2, and it looked at the calling number. And if I check regex route 2, you see it's the calling number that starts with 450 here. Right? The remapping function, I can use a, oops, I need to stop this call lead number of starting with 4 6s. Okay, so if I apply this route here, I have a call that started with 6666. And you see the call lead number was replaced. The 666 was replaced with 514. This is my regex route 3. So I can look at it here. Call lead 6666, 1, 2, 3, 4, 5, 6, 7. And then here there's a regular expression to remove the 666 and put 514 instead. So this is what we see in this call here. I have an example also of a specific number. So let's say I use a number 1111. Okay, so this is gonna use route specific 1. If I go here to route specific 1, the call-in number must be exactly this, and we will replace the call-in number with this number here, 992 something, and this will go out to the UAS. Okay. So what else do I want to show? This call trace is shown. Yes, I want to show you the signaling trace. So this is here. So you need to connect SSH to that SBC we're using now. And we can just do a TB sig trace. Oops, sig trace here. Just type TB sig trace like this. It will start a signaling capture. Okay, and it will be a specific file. So when you make a call to the system, you will see there will be some packets that are received and sent here. You can type Q to quit this, Q. Here, it will stop this. You can do TB setup. This goes to a specific folder and go in the TB sig trace folder, and this will have your file here. So you can extract this with FileZilla or WinSCP or anything that you can use to get a file like this. The other thing you can do is a TB report. So you have to go down here to the segment that's called the report, and you can just do here create TB report. In general, for a specific routing issue, we would want to have gateway to trace level 2. Gateway is the internal application that manages the calls. So you have to click here, applications, click on gateway, advanced parameters, and then you can put here trace level 2. The default is trace level 4. That's what you get on your systems usually, but you want to get more details, level 2. If we can't find it, you could also go to level 1, especially if you don't have a lot of calls, you could go straight to level 1. Save this, and then you can, you need to activate the configuration when you do this change. Once you've done the change, then you can do your calls, look at your call trace here, and then you can send us the call trace, the signaling trace, plus the TB report. To get more information on our wiki, we have here call routing page. This explains a bit how the call routing works. There's some links here you can follow for more details. Creating a first call route here. So it shows you how to create your route like this. Then you have troubleshooting for all kinds of things. This is for TMDR, TMG devices, media gateways, media support information here. ProSBC troubleshooting. I'll have a lot of things to troubleshoot this, plus Same thing for reaching our support team. And that's all I wanted to show today. One more detail is when we are in H248 mode. So, this mode here is when we receive SIP calls in the system. And also these are when PSTN network calls in the system. But these media gateways can also be controlled by H248 with an external media gateway controller. In that case, the call routing is not done inside the device, it's done in the media gateway controller. So the call routing is usually only used when it's like a standalone system. It can also be in 1+1 configuration, but when the call routing is done internally in the system. All these protocols are terminated inside the device, including SIP and all these TDM protocols. Okay? So that concludes the training for today. Thank you very much for participating.